How do percents relate to the ratios and the rates that we've been talking about? Well, first, we should start by cutting apart the word percent. Slice it right down the middle, and then we can define each half of the word. So we're going to start with the word cent. We should be familiar with this root word from things like the word century, cents in a dollar, centimos in a peso. What do all of these things have in common? If you're a French speaker, what does cent mean in English? This word translates to 100. And then per, we've already been working with. Per tells us for each or for every. So percent literally translates to for each 100 or for every 100. So if I'm looking at that as a ratio, this is a part to whole relationship. So my percent, whatever number I have, let's say 20%, would be 20 for each 100 is the same as my part to whole relationship. So if I'm ever trying to use percents, think of it as a ratio. Really, percents are just a special ratio that always has a denominator of 100. Let's try some practice problems. So if there's 20 students and 8 of them are girls, what percent of those students are girls? Well, let's set up our ratios. So we know that we have 8 girls to 20 students. I want to know the percent. I know that percent has to be how many per 100. So if we do some math here to find our equivalent ratio, to get from 20 students to 100 students, I need to multiply by 5. So 8 girls times 5 gives me 40 girls. And now that I have this ratio of 40 girls for each 100 students, I can tell you that that means that 40% of the students are girls. Make sure you have this example problem in your notes before continuing on. So what if I'm given the percent already and I need to find something out about the actual numbers? So 30% of students have overdue library books. If there's 200 students, how many of them have overdue books? We can set up our ratios exactly the same way, except now my question mark is in a different spot. Now I know what my percent is. I have 30 for each 100. And that's the same as how many for each 200. To find equivalent ratios, I need to figure out how I can turn this into this one. So if I have 100 and I need to get to 200, I need to multiply that by 2. So 30 multiplied by 2 would give us 60 overdue library books. Let's try a harder one. So if I have 40 cookies at my bake sale and 15% of them have peanuts, how many cookies have peanuts? Here's my ratios. 15% is 15 peanut cookies for each 100 cookies. And we want to know how many peanut cookies does that mean for every 40 cookies. So 100 to 40 is a little bit harder than 100 to 200. This wouldn't be a whole number relationship from here to here. So the easiest way to remedy that situation is to make a ratio table and add in a middle column that you can decide what number you want to put there. So the first column should have my original amount that I have. So in this case, my ratio is 15 to 100. The last column will be the relationship I'm looking for, how many peanut cookies to 40 total cookies. And then the middle column is any number that's going to help you with that process. So I've chosen 10 here because 10 is a common factor of both 100 and 40. I didn't have to choose 10, and it doesn't have to be a common factor. I could have chosen 400, which is a common multiple of both 40 and 100. And sometimes it's easier to go with a multiple so that you can avoid having any decimals in this middle piece. So if you want to change this to 400 to avoid the decimals, you're welcome to do so. If you can't think of what to put in this centerpiece, you can always choose 1, and it will work for any pair of numbers because 1 is a factor of every number. However, you might end up with some pretty unfortunate numbers to work with here. So go ahead and see if you can use this table to help you solve this question. Remember, you can change the 10 to a 400 if it makes it easier for you to solve. Let's try one more. So 80% of students have turned in their CWW permission slips. If 120 students turned in permission slips, how many students does that mean there is altogether? So I'm going to again set up my ratios. However, this time I'm given the part, students with permission slips, and I'm trying to find the whole. So my ratio looks a little bit different than it did before. My percent is still the same. I have 80 for each 100. Then over here, the 120 permission slips is my part. So that goes in the numerator. And then I'm trying to find the whole number of students. 80 to 120, not the easiest calculation to do, so let's have a ratio table help us out. Again, you can choose what you want to put for your stopping point in that middle column. If you're stuck and not sure what to choose, I recommend 40 for this problem, but you could choose a different number if you would like. Go ahead and finish solving this one on your own, and then you can continue working on the problems in the grid.